In multivariable calculus, much like in single variable calculus, sometimes we have the need for an implicit derivative. Now, just as a reminder, when you started in Calc 1, you often would see problems like this. Something like that. You'd say, okay, the derivative of y with respect to x is equal to 6x. But then you started encountering problems that were like this, that were like, and not only was the equation reliant on x, but it maybe was reliant on y as well. And you maybe couldn't separate the x's and y's into something nice and clean like a y equals. Like here you'd say, well, I can't really bring the y squared over. What could I do? So you had to introduce implicit derivatives where you'd say, well, the derivative of y with respect to x, and then you'd say, well, I've got to do 2y dy dx. And you did that because of chain rule. Y was an equation, so you said bring the 2 down, leave the y alone to the first, and then multiply by the derivative of that equation. And then you would get the dy dx's together. You would solve. In multivariable calculus, we have the same issue. And that occurs when instead of being a z equals or f of x, y equals, instead we have z as part of our equation, and it's not able to be separated to get a z equals. So we still have to find two partial derivatives with respect to x and y, but we have to say, well, we can't separate everything, so we're going to have to use some chain rule on z. Let's begin with the derivative of z with respect to x. So again, remember, this means that x is the variable, and therefore y will be treated as a constant. So to start with, the derivative of 7x is just 7. Now, I'm going to look at this next piece. I have 7xy and z. So 7xy and z. Remember, y is being treated as a constant. So here's how I'm going to kind of break this apart. I'm going to treat this as a function, and I'm going to treat this as a function, and I'm going to have to do product rule. So I'm going to say the derivative, or the first is 6xy, and the derivative of z is going to be derivative of z with respect to x, because that's the partial I'm doing. Plus, now I'm going to do z times the derivative of 6xy. And remember, y is a constant, x is the variable, so the derivative is 6y. Okay. Next, the derivative of 8yz squared. Now, since y is being treated as a constant, this is not going to require product rule, because 8y is just a constant multiplier. So I'm going to find the derivative just really of the z squared. I'll bring the 2 out front, and I'm going to, of course, just make this 16yz, and then we have to use chain rule because we don't know what the function z is. Now, we're going to proceed like we always do. We're going to bring all of the non-dz dx stuff to the one side. So again, I just move this over by subtraction. We're going to factor our dz dx's out. I'll put it right away. dz dx multiplied by 6xy plus 16yz. That. And since we're solving for dz dx, we will divide both sides by the thing in parentheses, which means dz dx is equal to 7 minus 6yz over 6xy plus 16yz. Next, let's tackle dz dy. Just do that to give myself a little more room. Okay, if we are going with respect to y, then we are treating x as a constant, and therefore the derivative of 7x will just be 0. And once again, on this other side, I'm going to need a little bit of product rule. So I'm going to start by, again, thinking of 6xy as one function and z as another. And the derivative, we'd have first times derivative of the second. Remember, now it's with respect to y, plus the second times derivative of the first. And the derivative of 6xy, if y is the variable and x is the constant, is just 6x. Now on this next part, because y is a variable, once again we have two functions multiplied together. So now we're going to do product rule. I'm going to make 8y a function, and I'm going to make z squared a function. So first times derivative of the second. I'm going to just make that obviously a 2, I hope. And then the second times derivative of the first. Okay, the calculus portion is done. I'm going to start moving the non-dz dy stuff to the left side. So I'll bring this stuff over. I'll have negative 6xz minus 8z squared. I'll factor that dz dy out and be left with 6xy plus 16yz. Just to recap here, I moved these two pieces over, factored that out, so 6xy is here, and then here it was 16yz right there. And now I will divide both sides, so I have dz dy is equal to negative 6xz minus 8z squared, 6xy plus 16yz. And there is my implicit derivative. Again, if this were just a function that was like z equals x squared plus y squared, you wouldn't need to do this process because you'd just say, well, the partial, let's say with respect to x, is just 2x. Right? The partial, you wouldn't have anything, but you need implicit when z is part of the equation, when you're being defined and z is part of it. If this video helped you, please like and subscribe for more math help.